We are in a race. The race is against time.
We have to build cities. We need them, but we have to make them in a different way.
We need a wave of innovation, not only for our way of life, but also the planet.
The consequences would be enormous if we lose this battle.
I'm Thomas Getz, executive editor at Wired magazine. At Wired, we look at the innovators and innovations that are changing our world. In the next hour, we'll see 3 stories from acclaimed filmmakers about the future of energy. We'll explore cutting-edge innovations in how we drive, how we live, and in our first story, how we fuel our cars. They are all ideas that promise to shape the path to the world of 2050.
The world has right now close to 1 billion cars, and we might double the number of cars on the planet by 2050. So if we double the number of vehicles, we really increase the amount of fuel they consume, and that's going to have a big, big footprint in terms of our demand for resources to move all those vehicles around.
We're pulling up carbon that's been stored underground and burning it in our automobiles and putting all that carbon dioxide into the atmosphere. If we don't reduce that, we could have changes in the climate that we could never recover from.
There's a number of forecasts for what type of transportation economy we could move into. One vision is that we will use more and more liquid fuels. Another one is we'll use more and more electricity. And right now, more of the industrial activity is focused around liquid biofuels.
The thing about a fuel is it's really unparalleled on a weight basis how much energy is in a gallon of fuel. And even if batteries develop as some of the advocates hope they develop, we're not going to see batteries running large trucks, and we're certainly not going to see an electrified air fleet. We're going to need transportation fuels for those that will directly replace the petroleum-based fuels that we're using today.
This has kicked off people looking at a whole range of other alternatives to petroleum in your tank.
Commercial production of ethanol as fuel started in Brazil in 1975. When we started the ethanol program, nobody talked about reducing emissions. This was not an issue at that time. First, and most important, we didn't have money to buy oil anymore after the first oil shock. We were importers of oil. And today, more than 50% of all cars use ethanol instead of gasoline.
Brazil made a very conscious choice to try to find a way to reduce their fossil fuel dependence. And they didn't have to look very far because Brazil's climate is ideal for growing sugarcane.
When you have sugarcane plantation, you have only 2 things to make, sugar and ethanol. My family has been in sugarcane business since 1955. And about 30 years ago, I thought there is opportunity to make more ethanol. And now we are producing 120,000 cubic meters of ethanol.
Brazil today has very close to 400 sugar mills. The overall sales is 30 billion US dollars, and this number is increasing.
If you look at how they make ethanol and how efficient the process is, it's really a model for all of us. They grind the plant up, extract the sugar from the cane. The sugar goes into these large fermentation tanks, which combines sugars together with yeast that naturally produces ethanol. They use the rest of the plant to generate heat to distill the ethanol and turn it into fuel. They also use that heat to generate electricity renewably, not putting excess carbon dioxide in the atmosphere.
Brazil has gotten to a point today where they're using about 40% less petroleum than they would be otherwise. But Brazil cannot supply the whole world with ethanol because they would have to cut very strongly into food production and into critical natural areas like the Amazon to make that happen. And this really boils down to the fact that there's only so much arable land, and growing fuel for our gas tanks is yet another demand on that landscape.
We cannot kid ourselves in thinking that we found a general solution for the world problems. I think we will have to face the world in this way today. We have no oil in very large quantities anymore. We have no coal transformed in a clean way. In the meantime, we have to do the best we can. And the best at the moment is that we can do biofuels.
Sugarcane to ethanol is an incredibly efficient process. You get out about 7 times the energy you put into growing the sugarcane. In the US, when we produce ethanol from corn, for every unit of input of energy, we get about the same amount of energy out. So we're really not gaining anything. We need a better process. We don't have to take what nature's given us. We can actually engineer plants and yeast to be more efficient, and that's the basis for a lot of the work that we're doing now.
What we need to look at, though, is which of the pathways that come out of this are not only good financially, but those that are also good in sustainability. And this equation is really wide open right now.
We are in a race to develop fuels. The race isn't with other countries, the race is against time.
To meet the immediate and future demands, we made the energy solution spring from the ground.
Brazil is the most efficient ethanol-producing country in the world. Sugarcane alcohol from Brazil can reduce the total carbon footprint by up to 70% compared with the gasoline.
The biggest challenge for fuel providers and car manufacturers is to reduce CO2 emissions over the next 20 years.
Demand for mobility will continue to grow. We believe that biofuels are very important because they help in an immediate way. All forms of fuel are going to be needed. Hydrocarbons, natural gas, biofuels, all of them are going to be part of the energy mix for the future of transportation.
Brazil has been very successful at taking a resource they had and finding the process to make that into ethanol. And people call those first-generation biofuels. We have lots of lab work around the world that are looking at the second generation. That's generally turning cellulosic material from, for example, weeds into biofuels. And the United States is very much at the forefront of the innovation part of the equation.
For centuries, we have been using yeast to consume glucose and produce wine and beer. We're trying to do something very similar, only we're engineering the yeast to consume that glucose and turn it into a fuel or a drug or chemical. We call this synthetic biology. And when I started in this area, many of my colleagues said, "Oh, Jay, this is great work, but where's the application? What are you going to do with these tools? Who cares?" Malaria is an enormous problem. In any one year, 1 million or so people die of the disease, and most of them are children under the age of 5. So we thought this was a great opportunity to engineer yeast to produce an anti-malarial drug called artemisinin. This drug is derived from plants right now, but it's too expensive for people in the developing world. So my laboratory engineered yeast to produce small quantities of artemisinin. Now that process is being scaled up and we'll have this drug on the market shortly, but at a substantially reduced cost. It turns out that anti-malarial drug is a hydrocarbon, and it's very similar in many ways to diesel fuel. We thought, gosh, we could turn our attention now to fuels. We could make a few changes in that microbe to turn it into a fuel-producing microbe. If we imagine that glucose is going to be our new petroleum, we need a source for that glucose. So the crops that we're looking at are crops like switchgrass. This is a native grass. It grows without a lot of water and on marginal lands, but we could turn into energy farms. The challenge, though, is that unlike sugarcane, it's very difficult to get the sugar out of that biomass. So we use what we call a pretreatment process to extract the glucose from the plant, and then we feed that glucose to a yeast that we've engineered to produce hydrocarbons. And that yeast takes in the sugar, and it changes its composition and gives us this high-energy molecule. They float to the top, you skim them off, you put them in your tank. But it takes a lot of work to get from that small test tube all the way up into the million-gallon tank. So we have to give it time, but I think that some of the discoveries that are happening might be applied by the end of the decade.
In terms of a sustainable equation for the planet, the role of biofuels is quite tricky. There are a variety of crops that do not compete directly with food, and finding ways to utilize those types of crops first, that's very attractive. So solving the science is part of the story, but then evaluating all of these new fuels in terms of the land use impacts that they could have, that is an even harder story than doing the good science.
Imagine that you could have one process that could take in sunlight and carbon dioxide and turn it into fuel. And imagine if that didn't involve growing anything at all.
The synthetic biologists are trying to take plants and make them do things that they wouldn't normally do. On the other hand, materials chemists like myself want to do artificial photosynthesis to improve on the process that nature does in real photosynthesis. We should follow the blueprint of plants converting sunlight into fuel, but take the approach that it could be much simpler. All we really need is a light absorber that absorbs sunlight. We also need a catalyst like iron or nickel. So when you see the hydrogen coming off of the photoactive material, that's an example of a semiconductor breaking the chemical bonds of water to make hydrogen and oxygen. Ultimately, our pieces are going to be contained in something that is easy to roll out like bubble wrap, where in would come sunlight and water. You would vent the oxygen to the air, but the bottom would wick out your liquid or gaseous fuel that then you could collect and use for our cars and planes and storage. Our goal is within 2 years to have the first artificial photosynthesis solar fuels generator that we can hold in our hands. And then get to scale beyond that time.
We're certainly not good at predicting the future, but to me, electric vehicles look like a sustainable option. We've heard proposals about things as far-fetched as nuclear-powered planes, and even some proposals to move freight around with lighter-than-air vehicles. And so, if the future in 2050 does include a fair amount of oil, what it means would be that we haven't deployed as many of these clean technologies as we already know are possible.
If you think about how long it's taken for us to build up the petroleum industry, we can't hope to reverse that overnight. It's a huge change in our infrastructure. Yes, we should have been working on it 30 years ago. We didn't. We're trying to make up for that, and that means basic research needs to be done now and by as many people as possible. We have a long way to go, but I'm confident that we'll get there.
In the future, 3D maps are going to help people get places more efficiently.
As we just saw, the race to produce cleaner energy is charging ahead. In the meantime, demand for cars continues to climb. By 2050, it's predicted there'll be 2 billion cars on the planet, and fuel consumption will have tripled. To keep pace, we'll have to radically change the way we drive. Here's our next story, Driven by Design.
The automobile came around. In many ways, it was the future. We thought of it as one of the more positive changes that had happened to society. Suddenly, our ability to get a job changed. We can live farther away with bigger plots of land, with better quality of living. It all looked quite good. But there are limitations to swearing by the car. If it gets congested, your quality of life drops immediately. To spend so long in the car, it's very inefficient use of fuel consumption. Things start making sense all of a sudden. It doesn't bring you closer to where you want to get. It actually sometimes brings you farther.
The average American spends nearly 300 hours a year in their car, 38 of them stuck in traffic. Annually, congestion consumes over $1 billion in gasoline in the United States alone. The inefficiency caused by traffic, both financial and personal, is enormous. Dirk Sheehan and Carmen White's story is not that unusual today.
Dirk works an hour and a half away in Warrenville, Illinois. Generally, he wouldn't leave work until 6 or 6:30, and I would say usual time for him to get home is around 8. Smell bad?
Usually when I wake up, I'm the only one up. Sometimes the kids wake up with my routine. More often than not, I don't see them in the morning. I think about my commute when I wake up. I check the traffic report, see if there's any delays. The worst case scenario, it takes me 2 hours to get to work.
We are already so limited in the amount of time he can spend with the kids. And our expenses are crazy high. We are spending $400 a month on gas. It takes away from our food budget, and we never paid for gas like that before, ever.
There's technology that would allow me to spend less time in the car, spend less money on gas, and spend more time at home. I'd be all for that.
The cost of traffic is people's time, it's fuel wasted, it's an emotional toll, it's a frustration. Utilizing the roads more intelligently is a much more efficient approach to the inability to have supply keep up with traffic demand.
If you took a satellite picture of the highway, you can see that there's actually a lot of open space. And if we had the technology for cars to drive more closely but safely, then you could increase the utilization of the road network.
What this means is that to be more efficient, to use less fuel, we need to see the road differently. We need cars that can navigate through the urban landscape in a radically different way.
Maps in the future are going to be able to help people get places either more safely or more efficiently. Today just helps you get from point A to point B. But what if I want to get someplace and use the least amount of fuel possible? Or if I've got a hybrid vehicle, I want to make sure I've got plenty of charge, not only get there, but to get back home. So information that is going to help people achieve the more efficient or the safer route is more detailed information about the road than a lot of people realize is possible to collect today.
Here in Chicago, Nokia's Location and Commerce Unit is developing the next generation of mapping. LiDAR, sonar, 360-degree video, all are components of what Nokia calls digital mapping.
We use 64 lasers that rotate and they collect data in a 3D way about the world. It creates what we call a point cloud of information. That point cloud allows us to measure distances then between the points that we collect. That system combined with the cameras with higher precision location detection through inertial measurement units, that whole data system allows us to collect 1.3 million points of data per second. Probably within 2 to 3 years, you're going to see 3D maps that are going to integrate the traffic information into your routing to help you understand. If I've got 5 different routes to take, which one is the most efficient today, given the way the stoplights are running, given the way traffic is running? All of those factors are going to be taken into consideration to make sure I've got the best route.
But better mapping that can integrate topography, infrastructure, and density is only part of the answer. Another key to improving transport efficiency is building cars that drive themselves.
Autonomous vehicle technology has a tremendous potential to improve efficiency of our road infrastructure.
By removing humans from the equation, we eliminate all the things we do wrong behind the wheel. Speeding, changing lanes too often, merging haphazardly. And by marrying autonomous vehicles with sophisticated 3D maps, we can make driving safer and more energy efficient. That next generation vehicle is being built right now by the Swedish trucking company, Scania.
The solution, as you see it, is that the vehicles can utilize intelligent maps, three-dimensional maps with traffic information. The vehicles will be intelligent and communicate with each other. They will talk to each other, they will talk to the infrastructure. And we will see completely autonomous driven vehicles.
The goal was to have multiple robots and see if they could go 60 miles fully autonomously.
My name's Helen Taylor. My husband John and I were very passionate about fuel economy.
Yeah, it's great to break world records, but that's not the be-all and end-all now. It's more important to educate people.
Together we're showing drivers around the world simple techniques to improve their fuel efficiency.
We run these education programs, get people on the road with us, and we finally tweak their driving techniques. Things like just checking your tyre pressures before you even get into your car. For every 1 PSI your tyres are underinflated, you're wasting 3% of your fuel efficiency. And the difference between 65 and 75 miles per hour, there's a saving of 23%. When you talk to the general public, they're very surprised that an energy company like Shell is trying to educate people how to save money, how to reduce CO2 emissions.
And here we have Shell sending us around the world to do that.
You always hope when you're on this planet that you can make a real difference in people's lives. When you get emails from people saying, I've saved this amount of money this year, now I can put food on the table, then you know you are really making a difference.
By displaying traffic density in the urban infrastructure in a revolutionary way, 3D digital maps will help create a more fuel-efficient future. But these technologies are limited by the drivers who sit behind the wheel. Some believe that for cars and trucks to be truly energy efficient, they will need to drive themselves.
The technology is coming into play through sensors and capabilities for cars to drive autonomously.
In 2007, the United States Department of Defense held a competition to see if a completely autonomous self-driving vehicle was possible.
DARPA stands for the Defense Advanced Research Projects Agency. They held a competition to develop self-driving robots that could drive themselves in traffic. The goal was to have multiple robots, turn them loose on a course, and see if they could go 60 miles in 6 hours fully autonomously.
Driving may be one of the most complex things we do every day. Drivers make dozens of decisions at any given moment. One study found that drivers were exposed to over 1,300 items of information per minute.
We make so many decisions when we're driving without even thinking about it. So in creating our vehicle, a great component of the enterprise was developing software to handle lots of sensors, feeding lots of data, and generating a bunch of potential paths that the vehicle might follow. And even though the robot doesn't have the ability to predict the future, by using this fast random path generation, the robot could anticipate a potential accident and choose a path to avoid it, because it's always thinking about what things could the car do next.
No one expects millions of cars driving themselves anytime soon. But there is a place where self-navigating technologies are being optimized to create the vehicle of the future.
We are on the Scania test track outside Stockholm, where we have basically, it looks like a highway, but it's a separate test track where we conduct our own experiments.
Scania, the Swedish trucking company, has recently begun testing its next generation of long-haul truck. Utilizing radar, sonar, and intelligent mapping, they've been able to drastically reduce fuel consumption.
We have this example with platooning, where we make use of the reduction in air resistance or air drag that you get from driving close to each other with heavy-duty vehicles. And in order to control this, you need to know where the other vehicles are, where their position, their velocity, their actions in the near future. And to be very close to the vehicle ahead of you requires that you have very accurate control.
If you look at robotics broadly, there's a wonderful set of research on people looking at schooling of fish and trying to develop the ability for robots to work together like that. So there are wonderful examples from nature of how cooperation can lead to more efficient resource utilization.
You can see it when people are competing in Tour de France. They platoon to reduce air drag. They are not bicycling behind each other that close because it's fun or because they are racing. It is because they are reducing air drag, sitting behind the man who is leading.
A truck traveling 55 miles per hour expends half its energy just to move the air around it. At 65 miles per hour, that number jumps to almost 2/3. Even if platooning can reduce the energy used by 10%, the savings would be substantial.
If a vehicle in front of another vehicle wants to brake, it immediately sends out the brake message to the other vehicles. So they actually brake at the same time.
The way we do this is we have an automated system. So now, for instance, if I take my feet off the acceleration pedal and turn the system on, the velocity is automatically governed by getting information from the vehicle ahead through its wireless system. We want these vehicles to maintain a short relative distance. So through this system, we can reduce the fuel consumption by utilizing the air drag reduction by 10%. And 10% would mean you will be able to save approximately 8,000 euros per single heavy-duty vehicle per year.
It may be some time before autonomous vehicles make up the majority of cars on America's highways. Nevertheless, some of these technologies are already making their way into our lives.
Now, this polar baby wants to sleep. Do you get to pick out books every day, or is it just something
I
that...
get to pick out books sometimes.
Okay.
When we look toward the future, the systems will absolutely make it safer and more efficient and less costly for you, and also make your life easier because you're spending less time on the roads.
The city begins to talk, begins to tell you where is there congestion, what's going on in different areas of town. Suddenly, the car becomes a part of a much bigger ecosystem. We can look at how cars interact with other cars, how car interacts with infrastructure, and us, the drivers, can start to make smart decisions about how to move around. Suddenly, mobility becomes a whole other thing.
No matter how much money they have, no matter how much oil they have, everybody has to go in a different direction.
We've seen that changing the way we drive can improve transportation efficiencies. But what if we change the way we build and live in our cities? That's the subject of our next story, Searching for Utopia. We'll travel to the United Arab Emirates and discover a city rising out of the desert. Let's take a look.
From the beginning, we've dreamed of utopia, a place where we could live in harmony with each other and in balance with nature. Many have imagined it, tried to design it, but the dream always slipped away. Then I heard they were building a new city called Masdar, near Abu Dhabi, in the Arabian desert. It sounded like an unlikely place for utopia, and I wanted to see it.
The last half century has been a pretty bad time for the making of cities, mostly. The natural tendency has been to accommodate to the automobile more than anything else. Try walking around Abu Dhabi. It's impossible. You have to take a car everywhere. Dubai, the same thing. They are among the least pedestrian-friendly places in the world. They are not green by any other measure either. And these are not easy things to fix.
Masdar is still under construction, and it doesn't look like much from the highway. But they claim it's going to redefine the way cities are designed, built, and powered.
Masdar City in Abu Dhabi will be the city of the future and the role model for the world.
Once you see what they've envisioned for this utopian city, it's very impressive. It's carbon neutral, pedestrian friendly, and powered by renewable energies. But I do notice we're going to have to change our relationship with cars.
Welcome to Masdar City. أهلا بكم في مدينة مصدر.
We are driving in the bowels of Masdar City in an electric transportation system. It's slightly unnerving to sit in this for the first time. Where are we going?
The first big move the architects at Foster & Partners made was to put all transportation underneath the city, leaving the streets of Masdar totally free of cars. The place reminded me of a medieval city, and actually, many design elements are adapted from ancient Arabic towns and villages.
It's all about looking back into history to move forward. There's some very, very simple ideas that have a huge impact. This is a pedestrian zone, there's no cars here. This has enabled us to push our streets together to take the advantage of the shade, channel the cooling breezes through. The whole scale here is based on the human being, it's not based on the motor car. As soon as you lift up the pedestrian plane by 7 meters, you've suddenly captured this breeze. What you can see here in the balcony is we've got a modern interpretation of an ancient Arabic screen. What we must avoid is direct sunlight hitting any piece of glass. As soon as the sun hits the glass, the heat's transferred into the building and we have to use more energy to cool it down.
Can this really make all that much of a difference?
Yeah, absolutely. For example, downtown Abu Dhabi, 60-meter wide streets, black asphalt, mirrored, reflective buildings, no relief from the sun. On a day in September, the air temperature in both places was 39 degrees. In Abu Dhabi, the temperature measured at the asphalt was 57 degrees. In Masdar, the temperature measured on the ground is 33 degrees, so we've actually lowered the air temperature. We're trying to do as much as possible with as little as possible.
These simple design moves cut air conditioning needs by 60%. But this place is also technically very sophisticated. The roof panels not only provide shade, they also generate electricity. And the walls themselves are made of glass-reinforced concrete, literally sand taken from the desert. Everything here is geared towards maximizing energy efficiency.
Masdar does represent a whole different value system. It represents an acknowledgement that eventually everybody has to go in a different kind of direction, no matter how much money they have, no matter how much oil they have, no matter anything else. All of the cities here in this part of the world have come out of nowhere. There was nothing here not so long ago, except small settlements in the desert. And then all of this oil and all of this money, and suddenly, you know, wham, these cities started popping up. But they sprung up in a false love of a Western model that was already out of date. The model of the late 20th century automobile-based, energy-hogging city.
For most of the world, energy is very expensive. But the United Arab Emirates is sitting on 10% of the world's oil. And energy is cheap. So cheap, you can run a ski slope in a shopping mall and build the world's tallest skyscraper. But even here, cheap energy won't last forever, and the people behind Masdar are determined to find alternatives.
One of the most crucial aspects of our energy modelling and scenario quantification is how much energy in total is the world going to use in 2050.
The Scenarios team is a bunch of people with rich imagination, I would say.
We have political scientists, economists, geopolitical experts.
Really, we try to simplify the complexity all around us.
We in the Scenarios team are currently putting a lot of attention into cities and city development.
A lot of mega cities are going to be built in the coming decades.
We're talking about the equivalent of a new city of 1 million people every week. That is an incredible demand.
Most of the world's resources are consumed by the cities.
What if we could offer a blueprint for a better city? Public transportation, information, energy. We understand demand will rise. We understand that current supplies will struggle to keep pace. So we have to, of course, find ways of bridging the gap between the demand and the supply.
Decisions that we take now are going to have a major impact on decades to come.
There's enough oil under these sands to last 150 years. But fundamental to the Masdar ideal is getting energy from renewable sources, from geothermal and wind, and most of all, from a source they have in abundance in the desert, the sun. This field of solar panels makes more than enough electricity to run Masdar, and the excess power is sent to the Abu Dhabi grid. But silicon panels are expensive, and the price of solar power needs to drop if it's going to be competitive from Africa to Asia to Arizona. In the future, Masdar hopes to get energy from this prototype called the Solar Beam Down. Using highly reflective mirrors, the solar beam down may generate power more cheaply and ecologically than silicon panels. The mirrors bounce the sun's rays up to the tower and then down to a point. Reaching a temperature of 600 degrees, steam can be generated to run turbines to make electricity. There's just one problem. Neither of these solar technologies work at night. So Masdar needs to draw power from the grid when the sun goes down. And that power comes from natural gas. The reality is, it's just not yet possible to power Masdar entirely without fossil fuels.
The great challenge with Masdar will be, how do you make it a place that will not be just this ideal city that no other place could actually aspire to because it doesn't seem real? What Masdar has to be is a laboratory that develops things that then can be applied in existing cities all around the world, because that's where it will pay off. There's no payoff if it's just about itself. The payoff is, how can everything it's trying to do matter in the rest of the world?
Right now, there's only a store, 2 restaurants, a bank, and a few hundred students living here. It's too early to tell if Masdar will work as a city when it's finished. But much has been achieved. They are carbon neutral and largely powered by renewable energies. Solutions here won't work everywhere, though. Many cities are in cold climates, and cooling is not their energy problem. They need to let sunlight in, not keep it out. Cities like Los Angeles or Houston are built around cars. Can Masdar's lessons be applied to them? Still, it's a step in the right direction, and it's impressive that this step is being taken by a country that doesn't need to take it. I met a guy who said actually they did need to take it. He took me to the desert to explain.
God says, وَعَرَضْنَا الْأَمَانَةَ عَلَى السَّمَاوَاتِ وَالْأَرْضِ وَالْجِبَالِ. God talks about man's place in the universe, that this world is a trust. And God offered this trust to the mountains, to the heavens, to the land, to earth. And all refused it, refused to take this trust. But man, being adventurous, a bit vain, maybe too ambitious, being man, accepted it. Now, accepting it, there is a responsibility.
Taking responsibility isn't always easy. Utopia may be unattainable, but we must reach for it. And Masdar does give us a clue to what cities will be like in the future. They may not look quite like Masdar, but they will be shaped by the same concerns, by energy, where it comes from, and how it's used.
The way we've been building cities lately is unsustainable. We can't go on building them that way. But to say that we can't build cities the way we have been building them doesn't mean we can't build cities in the future. In fact, we have to build cities. Cities are the essential statement of human civilization. So we will continue to make them. But we have to make them in a different way.
What we've seen is that the world of 2050 won't look drastically different from the world today. But the challenges of a growing population and increased energy use demand real solutions. It's innovations like those we've just seen that will be critical in charting our path to the world of 2050.